Good morning, students. Today we are going to discuss about the types of storage batteries and comparison of batteries. Now we are going to discuss about where we are using the batteries. Usually we use the batteries for our household purpose. Example, we used these batteries in cameras, we used these batteries in watches, handycam, remote transistors, torchlight, etc. Each and every device need the battery. So battery provide the power supply to the particular devices. Those are not needed the connection, electrical wire connection. Without having the connection, we use these batteries. For running, for backup purpose, we are using these batteries. Batteries are very important. Generally, these batteries are used at cell towers and at backup centers or in the computer backup center. We are using the batteries. A particular instant of time, we use these batteries to protect our systems or to protect our files from the sudden breakup of the power supplies. We can also use these batteries in a particular areas like coal mines, electrical substations, telephone exchanges, generating stations, so on. In the telephone exchange, whenever power is off, until the power comes, we use the batteries to run that particular telephone exchange. Generating station, in the generating station, initially they require some power. That power is generated or given from the batteries. The objective of this topic is we having some objectives. After completion of this period, you would be able to know about what is a cell, what is a battery, what is the cell, and what are the different types of cell, advantages of secondary cells over primary cells. So the thing is, generally we having a little more confusion in between cell and battery. We are going to clarify that confusion in this class. What is the cell and what is the battery? What are the different types of cells? And what are the primary cell and what are the secondary cell, and comparison between those cells. We can also having the objective like that comparison between lead acid and nickel iron cells. What is the importance of lead acid cell and nickel iron cell? What are the different properties we are using? What are the different materials we are using? Next. And we can also discuss about the maintenance free batteries. That is, the general batteries require some maintenance, but coming to the another new technologies, we need not to go for the maintenance. We having the another type of version that is called the maintenance free batteries. So now we are going to discuss about battery. What are the batteries? In general life we can having the batteries we are seeing in day-to-day life. In the wristwatch we use the battery. In the cell phone, in the remote we use the cells. In the clock watch we are using the batteries. In the toys which are played by the students, we also using the batteries. The batteries are very important in day-to-day life. They provide the electrical power without having any connection with the wire or plug. Directly the batteries will having the energy. That energy is supplied to our devices. You see a different types of batteries. So these are the alkaline batteries. Another type of batteries, you can see a different ranges are there depending on our requirements. We have the 2.5 volts, 5 volts, 9 volts, 12 volts, like that we having the different volts are there. You see here button cell. Generally this type of button cells are used in the wristwatches and in the computer for the backup purpose. If some of the files are always running in the system, that will be possible by using button cells. You can see. Now we are going to discuss about the what is the cell and what is the battery, and also we try to discuss about what is the difference between the cell and battery. You can say that what is a cell. Generally cell is nothing but a chemical body which having the two electrodes which having the charging capacity and discharging capacity. Generally that is coming to our definition. The definition is a cell is a single unit at the base voltage. A cell is a chemical unit, one unit at the base voltage. It will provide the some basic voltage. Coming to the battery, what is a battery? A battery can be a single cell or multiple cells connected together in series or in parallel. That is called a battery. So the meaning is the battery is a simply we can say a single cell, also called as a battery, or the more number of cells, they may be connected in series or may be connected in parallel depending upon our requirement. That set of batteries or that set of cells are called as the battery. You can also say that source of direct current electricity or electrical energy produced by the batteries. The meaning is direct current. The batteries are source of the direct current. We charge in the batteries. That electrical energy is stored in the form of the chemical power. That chemical power is converted into the electrical power. We need not to go again to the mains. Directly we use that power, the 2.5 volts, depending on the specification. That specification of power we will use. You can be used as a standby power. The batteries are used by the standby power. The meaning is standby power means wherever you want you can use the cells, you can take that cells, need not to having the connection with the power supply. After charging we can remove that connection, directly we can use the batteries. These batteries are used in automobiles, boats, mines, aircrafts, ships, portable electrical or electronic equipment, so on. The meaning is automobiles. In the automobiles, for the starting we use the batteries. Directly we need not to go for the physical or mechanical pushing. Directly we having the self acceleration is there by using the batteries. The boats, mines, aircraft, ships, toys, so many things are there. All these are used in the batteries. These are made in different shapes and different size and different ratings, that is the different voltage values. You can say a single cell, a cell is a source of EMF in which chemical energy is converted into the electrical energy. The meaning is we can know that a cell is a single quantity. It is produced or it is the source of the energy, that is the chemical energy. That chemical energy is converted into the electrical energy. Chemical reactions are takes place in the particular cell. The potential difference is established between the two electrodes. That potential difference is used as a voltage or source. The battery EMF of a cell is around 1.5 to 2 volts. A single cell having the range is 1.5 to 2 volts. So may have the different values. To get the appreciable DC supply, cells are connected in series or parallel. This is plays a important role in industrial and commercial application. Depending on our application, we use the series connection and parallel connection. So what are the types of cells? We having the different types of cells are there. The cells are mainly divided into two types. The first one is the primary cell and the second one is the secondary cell. Primary cell and secondary cell. So what is the definition of the primary cell and what is the statement of the secondary cell? Now we are going to discuss. Primary cells. What are the primary cells? The primary cell is the cell in which chemical action is not reversible. The main important point is chemical action is not reversible. The meaning is whenever we having the chemical action, it does not be reversible. Once we used, we can use. We did not reuse the cell. That cells are called as the primary cells. Examples are voltaic cells, Daniell cells. These three Lake cells and dry cells and Western standard cells. These are the primary cells which does not having the chemical action, that is the chemical action is not reversible. What is the description of the primary cells? Primary cells, the primary cells consumption of one of the plates takes place. For example, in voltaic cells, zinc dissolves in H2SO4 and forms the zinc sulfide. But zinc cannot be formed from the zinc sulfide. Zinc plate goes on consuming as cell delivers current. To renew the cell, new zinc plate is placed fresh electrolyte. The cell in which chemical action is reversible are called the secondary cells. You know that is exactly opposite to the primary cell. The cell in which chemical action is reversible. If the chemical action is reversible, that type of cells are called secondary cells. No consumption of the any plate. Here there is no consumption of the plate. What is the meaning of consumption of the plate? The plates are damaged during this chemical reaction. Coming to the secondary cells, there is no consumption of the any plate. Plates are chemically changed, can be brought to original condition during the charging. We having the two types are there. Charging is there, discharging is there. At the charging we make the plates are coming to original condition. During the discharging, chemical energy is converted into the electrical energy. During the charging, electrical energy is converted into the chemical energy. We already know that charging and discharging. Charging means the electrical energy it taking, the cell is takes and it is stored in the form of chemical energy. Discharging means already stored chemical energy is converted and passing through the battery as a electrical energy. So what are the different types of secondary cells? Now we are going to discuss about the secondary cells. Already you know that secondary cells means the chemical reaction is reversible. that is called as the secondary cells. Secondary cells are two types, mainly divided into the two types. First one is the lead acid cells. Second one is the alkaline cells. Again, these alkaline cells are divided into two types. One is nickel iron cell or Edison cell, and second one is nickel cadmium cell or Junger cell. Nickel iron cell means here we are using the electrode as nickel and iron. Coming to the nickel cadmium means here the electrodes are, one is the nickel, another one is the cadmium. That is the only difference we having. So remaining all are same and their functionality is different depending on using this material. Now you see here we try to discuss about the lead acid cells. So what are the lead acid cells? You can see lead acid cell, what they are using. The substances of the cell which take active part in chemical reaction and hence absorbs or produce electricity during charging or discharging are known as active materials. What are the active materials and what is the importance of the active materials? These active materials can having the capacity of observing or produce electricity during the charging or discharging. So we try to find the active materials. In the lead acid cell, the active materials of the lead acid cell are anode or positive plate or lead peroxide. Anode or positive plate is made up of with the lead peroxide. Another one, that is the cathode or negative plate, is made up of with the spongy lead. Electrolyte, what electrolyte we are using is the dilute sulfuric acid. The first method, first plate is the lead peroxide, another one is the spongy lead, and the dilute or electrolyte used is dilute sulfuric acid we are using. These are the main active elements which we are used in the lead acid cells. So coming to the active materials of lead acid cells, you can see lead peroxide, combination of lead and oxygen is called as lead peroxide. Dark chocolate brown in color, and it is made up of one atom of lead and two atom of oxygen. That is called as a lead peroxide. It forms anode or positive plate. The lead peroxide forms the anode or positive plate. And the next one is spongy lead. Spongy lead, that is nothing but pure lead in spongy or porous condition. It forms cathode or negative plates. That is, the spongy lead forms the cathode or negative plate. Next one, working principle of lead acid cells. Sulfuric acid molecules break up into hydrogen positive ions and sulfate ions. You can see how the lead acid cells are works. We already discussed that in the lead acid three active materials are there: lead peroxide, spongy lead, and the electrolyte is diluted sulfuric acid. So now we go for the how it is working. The sulfuric acid molecules, whatever the molecules present in the sulfuric acid, break up into hydrogen. That sulfuric acid is break up into the hydrogen positive ions and sulfate negative ions. Positive ions and sulfate negative ions. Hydrogen ions move towards the cathode and becomes atom of hydrogen. Whenever these hydrogen ions moving towards the cathode, they becomes the atom of hydrogen and they escapes out as hydrogen gas in the form of gas. Sulfate negative ions move towards the anode. Moves toward the anode. That is reaching anode. The reaching anode gives two electrons to it and reacts with the water from H2SO4. H2SO4 and oxygen. Oxygen attacks lead anode, that is oxygen attacks lead anode and forms the lead peroxide that is the Pb0O2. Even you can measure the potential difference across the terminals by disconnecting them from supply. Now the cell can deliver current to the load. Now the cell can deliver current to the load. Now we are going to discuss about the construction of nickel iron cells. Already we discussed about the lead acid cells. Very simple way, that is what are the active materials are there, what happened and how it is working and how it is converting chemical energy into the electrical energy, hydrogen ions and the oxygen ions. Now we are going to discuss about the construction of the nickel iron cells. Already we know that active materials of nickel iron cell are positive plate, negative plate and the electrolyte. What we are using, positive plate, here we are using the nickel hydroxide. Small quantity of graphite is added to increase the conductivity of the positive plate. The another one is the negative plate. Negative plate is nothing but powdered iron and its oxides. We are using the negative plates, powdered iron are and its oxides we are using. Electrolyte, the third one is the electrolyte. We are going to use the potassium hydroxide. What we are using is potassium hydroxide. Like this, these three are the active materials which we are using in the nickel iron cell. That is the positive plate is the nickel hydroxide, negative plate is the powdered iron and the electrolyte is potassium hydroxide. Small quantity of lithium hydroxide is added to increase the capacity and life of the cell. If we want to improve the life of the cell, we use the lithium hydroxide to the small quantity. Active materials of a nickel iron cell are already we know that embonite sticks are placed between the positive plate and negative plate to prevent the short circuit. The thing is these, these two plates are dipped into the electrolyte. In order to avoid the short circuit, we use the embonite sticks are placed between the positive plate and the negative plate. Number of negative plates equals to the number of positive plates 1. How many number of negative plates we are using? More than one positive plate should be used. Extreme negative plates are electrically connected to the container. Electrically contained to the container. Like this, we make the setup to run freely. And next, we are going to discuss what are the advantages of the secondary cell over the primary cell. We already know that primary in the primary cell there is no any reverse chemical reaction, but in the secondary cell we having the reverse chemical reaction. The meaning is The primary cells are does not the primary cells are not reusable. The meaning is we don't recharge again and again. But coming to the secondary cell, we can recharge again and again. So that is the main difference. Now we are going to compare these two. One of the electrode does not consume. The meaning is in the secondary cells the electrodes are not consumed. In the primary cell the electrodes are consumed. Once consumed, that's all. We don't use the cell. The main advantage of this secondary cell is one of the electrode does not consume. Charging and recharging process is reversible. The already we discussed, we can charge and discharge repeatedly. The meaning is we use and we can also reuse the battery. The voltage of the cell is more. Secondary cell having the voltage capacity is more compared to the primary cells. Life of the cell also is more compared to the primary cell. Primary cell once we used, that should be throwable, it does not useful. But coming to the reusable or secondary cells, we can use so that life of the cell is improved. And also efficiency is high. So now we are going to discuss about the comparison between the lead acid cells and the nickel iron cells. The meaning is we try to compare the basic parameters of the lead acid cell and nickel iron cell. Now we are going to see here. So what we are using in the lead acid cell? What are the active elements? Like that we try to discuss. Now we see the slide. So what value they are giving? You can see. The first column provide the particulars. Second column lead acid cell. And the third column is nickel iron cell. So we having the particulars are there. Particulars means what are the parameters deals with the cells. Those are called as the parameters. Positive plate, negative plate. So coming to the lead acid, positive plate, lead peroxide we are using, and sponge lead is used for the negative plate. Coming to the nickel iron cell, positive plate is used as nickel hydroxide. What we are using is nickel hydroxide we are using. Negative plate we are using iron. The negative electrode or negative plate we are using in the nickel iron cell is iron. Next, coming to the electrolyte. What type of electrolyte is you are using in your batteries? Electrolyte, that is 2.0 volts for cell. Here we are using the potassium hydroxide we are using. Average EMF, that is the average EMF is given by the lead acid 2.5 volts per cell and 1.2 volts per cell we are using. Charging capacity, how much it are having? The 90 to 95%, 1.7 port per cell we are using. Efficiency is there 90 to 95%, amp power 70 to 80%. You can compare these two, which are the best. That is the lead acid cells are comparatively more advantageous. Again we having so many other parameters are there. can see the another particulars are internal resistance how much, cost how much, life is how much of the nickel iron cell and nickel acid cell and nickel iron cell. That is the internal resistance around 0.001 ohms to the 0.002 ohms. That is in the nickel iron cell it having the 5 times that of the lead acid cell, more than that of lead acid cell. The cost of the lead acid cell is low, and a nickel iron cell is high, but the maintenance cost of the lead acid is high, but nickel iron cell maintenance cost is low. That is the main difference, main feature we are using. That is, the cost is high but the maintenance is low for the nickel iron cell. That's why we sometimes prefer the nickel iron cells. The life, how much life it have. Coming to the lead acid cells, 1250 chargings are used, but coming to the nickel iron cell, it having the 5 years chance. Again, another parameters are there. Mechanical strength, how it having the mechanical strength, rate of charge or discharge, discharging period, container material, quantity of electrolyte and size. These are the another parameters. Coming to the lead acid cell, that mechanical strength is very less, but in the nickel iron cell the mechanical strength is more. Rate of charge of discharge is low. In the nickel iron cell high. The discharge period comparatively smaller, but in the nickel iron cell it is a longer. Container material what we are using is, here we are using the glass or ebonite or hard rubber materials we are using. But in the nickel iron cell the container material is used as the steel or airtight. Quantity of electrolyte we needed is more. In the lead acid cell, but in another one it is need the less. The size, coming to the size, lead acid cell is the more size and the nickel iron size is comparatively low or compact, we can see. So now what we are discussing is, we are discussing about the secondary cells. In the secondary cells we having the two types, that is the lead acid cell and the nickel iron cell. What we are discussing is, what are the different active materials in these cells and what are the strength and what are the weaknesses of these two cells. To know that the particulars we discussed, by using these particulars we can choose which type of battery or which type of cell is useful or preferable for our application. So another one is the maintenance free batteries. This is another type of battery, maintenance free battery. So what is the maintenance of the battery? Why we need to maintain the battery? The meaning is, secondary cells or primary cells. Primary cells are used and throw type of materials. We need that to have the maintenance. But in the secondary cells are rechargeable. Again we can reuse these charges. The thing is, sometimes we need to add some dilute water in that particular cell. So that is called as the maintenance. Nowadays we are getting the maintenance free batteries. The thing is, directly we can use those batteries. Whenever it damages, it not working, then we can remove and replace with the another one. So what is the advantage of the maintenance free batteries? Where we are using the maintenance free batteries, now we are going to discuss. Before going to discuss about the maintenance free batteries, we just look at normal batteries. So maintenance free batteries we can compare with the normal batteries. What is the difference? The first difference is chemical energy contained in the active materials are converted into electrical energy. What happening is whatever the chemical energy contained in the active materials are converted into electrical energy. This process is known as electrochemical oxidation reduction reactions. The meaning is the electrical activity or the materials are converting into the energy, that is called as the electrochemical oxidation reduction reactions. Reduction reactions. What are the maintenance free batteries? Now we try to see. Maintenance free batteries. You can see how we are saying maintenance free batteries. Lead acid battery has been used as a source of secondary DC power for ages. The meaning is from the beginning what they are using is lead acid batteries. Lead acid batteries uh, has been used as a source of the secondary power from ages. Maintenance free batteries. Generally, we know that lead acid batteries are used from the source of secondary DC power from the ages. They require replenishment of water frequently. The thing is, these secondary cells are always replace or pour the water into the battery. Most significant development has been taken in storage batteries. That development is nothing but maintenance free batteries, which is known as the maintenance free valve regulated lead acid batteries. Maintenance free valve regulated lead acid batteries, VRLA batteries. VRLA batteries are user friendly. So these are generally used at the, you can say nowadays we can see these are in the day-to-day life, that is at the batteries UPS setup. We can use these type of batteries for the UPS, and for the bike cars we are using the maintenance free, that is the maintenance valve regulated lead acid batteries. Maintenance free valve regulated lead acid batteries. What is the VRLA technology? Now we are going to discuss about the VRLA technology. In case of lead acid batteries, in the discharging process, lead dioxide is positive active material. Discharging, lead dioxide is the positive active material. Spongy lead is negative active material. Both reacts with the sulfuric acid and forms lead sulfate and water. The meaning is internally they produce the water, so that we need not to maintain the water levels in the cell or battery. During the charging process, the process is reversed. Positive plate and negative plate generates the oxygen gas and hydrogen gas respectively. Oxygen at the positive plate occurs before the evaluation of the hydrogen gas at negative. This feature is utilized in the VRLA batteries. That is, these two gases combinedly forms the water. In flooded cells, oxygen gas evolved at positive plate and bubbles through the electrolyte released through the vents. Oxygen gas evolved at positive plate is transported into the gas phase through separator medium to negative plate. Separator is highly absorbent glass matte type. It is of high porosity material designed to have more volume in excess of electrolyte volume. Oxygen gas find an impeded path to the negative plate. Oxygen gas gets reduced by reaction with spongy lead at the negative plate. It turns a part of it to a particular discharge condition, effectively suppress the H2 evaluation at the negative plate. This is known as oxygen recombination principle. Oxygen is recombined is here. A part of the negative plate is reverted to original spongy lead. So negative plate keeps equilibrium between the amount which turns into spongy lead and amount of lead which turns into lead sulfate. Now we try to see the oxygen recombination principle, how it is having the reaction chemically. You can see there reaction at the positive place, H2O2 divided into half O2 plus 2H plus and 2 negative electrons are released. The reaction at the negative plate, that is a lead place of O2, that is the lead oxide plus electrolyte, that is H2SO4. Combinedly we are getting the lead sulfate and H2O, that is here water is generated with the reaction of the chemical reaction. We need not to externally pour the water into the batteries. So this is called as the oxygen recombination condition. The lead sulfoxide plus two hydrogen ions plus 2 electrons combinedly we get the lead and H2SO. The lead is the plate and the H2SO is the electrolyte. Already we generated the H2O2 and we get the electrolyte. The total reaction at negative plate is of O2 plus 2H, that is H2O. It generates thus the recombination technology makes the battery virtually maintenance free. So like this, the maintenance free batteries are by themselves they create the water in that battery with itself. So that's why we need not externally add the batteries into the battery. This features makes the battery maintenance free battery. These maintenance free batteries are used, so many applications are there nowadays. We having the more applications. These maintenance free batteries are used in the battery backups for the UPS and also used in the bikes, cars and so on. All those things we are using. So now we are going to summarize what we learned in this period. So now we get the summary. Till now what we discussed till now we discussed about a cell. What is a cell? What is a battery? What is a battery? What are the types of cells we discussed and advantages of the secondary cells over the primary cells. And also we discussed about the comparison between the lead acid and nickel iron cells. We also discussed about the lead acid and the nickel iron cells. Next we discussed about the maintenance free batteries, how they are working, what are the importance. We also discussed about the primary cells and secondary cells, and again secondary cells they are divided into two types. That is one is a lead acid cell, nickel lead nickel lead acid cell and the nickel iron cells and the properties and what the particulars of those cells we discussed, and at last we discussed about the maintenance free batteries. Now we try to solve some problems to understand what we understanding from that period. So what is the average EMF cell of a lead acid cell? So what is the answer? 10 volts, 35 volts, 1.2 volts. Generally the value is the 2 volts. Can say that. Another question is life of a nickel iron cell. Nickel iron cell, you know that 5 years. Already we discussed that is the 5 years. Next. Another question is in a lead acid cell the anode is dot lead oxide, lead peroxide. In the anode is lead peroxide. In nickel iron cell, the electrolyte is sulfuric potassium hydroxide. And the questions we are using frequently is the important frequently used questions are the compare lead acid and nickel iron cells. And what is the principle that we are using in a VRLA batteries? Very good principle, that is the electrode is self-generate the water from that there. And also we what is the principle that we are using the VRLA battery? That is the oxygen recombination principle we are using. Another question is what is a battery? Converts electrical energy into a mechanical energy, converts chemical energy into the electrical energy, converts mech to electrical energy, all of the converting the chemical energy into the electrical energy. Chemical actions are reversible in negative plate. Takes in a which cell? That is, you know, the reversible is in the secondary cells. You know that. We know that. Now we having the another important questions. There list the advantages of secondary cells over primary cells. What are the differences between primary and secondary cells? These are the important questions. Frequently asked questions these are. The last question is write a brief notes on a maintenance free batteries. So you try to write the notes on the free battery, free maintenance free batteries. So like that we are discussing about the different types of batteries and the comparison of the batteries, how they are using, and about the maintenance free batteries. So next class we are going to discuss about the different type of switches and connectors and so on. We try to discuss in the next class. Thank you for listening my class. If you have any doubts, you can ask me. Thank you.